Look at this. Let's look at this. So what we want to is we have those devices. Look as a subscriber to our this weather station, this data. Once the data have some change, the weather station will update this device through this weather data object. So that's the main idea, and we do have this class diagram here. So all the observers, they are all subscriber. They all have an update function. Okay, and whenever something changes here in this concrete subject, it will call the update function of all the subscribers, so that every subscriber knows what happened, and it will make change accordingly. Okay, and every observer have its own update function because they want to do update differently, right? Like the weather station, this device will display on the screen. Maybe you have a printer will just print it out on the piece of paper, and you have a big screen hanging in front of the building. That's a different way of update, right? And I do want to put this out. Okay, I cannot show this now, but yeah, I will make this code available. That's what I wrote last time. We have the example display observer and display and weather data. Just I need to take it over here. So it's going to be this weather data with a measurement changed. Whenever it's changed, we call the notify observers. And this is how we set the measurements. See, when we set the measurements, we call the measurement changed. So every time when something is updated, we call the change method, and the change method will call the update function of every subscriber. See, here we have a for loop, right? So you cannot get that idea how the subscriber and publisher they happen over there, right? Okay, so I'll make this code available online. So have any question about this subscriber, this update observer? You got the main idea, right? So just instead of keep pulling the information, you get push. And a lot of like Gmails, this Facebook Messenger, they're all like kind of not you're not pulling all the time. Just push to your place. Okay, another method. So I'm gonna cover some of the design patterns that I have experience. I think that's kind of important, and there are a whole bunch of design patterns there. I cannot explain every one of them, but I can. If you are into this design pattern, you want to do more research, I can give you a website. It's on the slide. The website, it will give you a very quick overview of every of the design pattern. And if you want to learn more deep into that design pattern, there are a whole bunch of book there, including this a head first design pattern, which can kind of explain everything pretty clearly, but the pace of that book is kind of slow, so and it's not necessary to follow that step as it's too slow. The website I give you is I think it's a good one, and the book written by the Gang of Four, you search for the GOF Gang of Four design pattern, you will find their books. They kind of give you a systematic description of all the design patterns. Okay, but if you want like quick overview of every design patterns, sometimes you just need that. You can go to this website. Actually, I recommend it because I find it pretty useful for me. It's on the slides, so you can check it later. Okay, the template method. So why we call it template? Let me just give you this class diagram. I think you should be able to read this class diagram and let me know what is the main idea of template method, template design pattern. See, we have a framework class, and we have this. See, the template method. Okay, and it has step 1, step 2, step 3. Actually, on the right side, you can see the step 1 there, step 1, step 2, step 3 here on the right side. It's actually, it says inside this template method, we call step 1, step 2, and step 3. Right? Think about like making coffee and make a tea. Make a cup of coffee and make a cup of tea. Right? So they share some steps there. Like pour the water, but sometimes you put coffee inside, sometimes you put the tea inside. Just then you serve that cup to your customer. Sometimes some steps they share in common. Some steps are different, right? So here the main idea is we have all the step. Okay, maybe if the step 2 is different, I have an application class 1 which inherited from the framework class, but override the step 2. Okay, assume this application class 1 is making coffee, application class 2 is making tea. So the first step is like almost the same. They take a coffee, they boil the water, they have boiled water, something like that. But the step 2, they are different. One is maybe put coffee inside. The step 2 is put tea inside. So what we want to do is, that's the only difference is the step 2s are different. So why we call it template method? Because in the template method, template design pattern, it's because it has a template method. In the template method, we all do things like step 1, step 2, step 3. That's a template. Okay, I get into the class, get into classroom, talking about the class, give a lecture, then step out of the classroom. So the first step and the third step, they are all the same. And maybe step 2 is different. So we have some classes inherited from this framework, and we override step 2. So when you call the template method in application 1 class 1, it will call the superclass step 1. Then it will call the subclass step 2. Then it will still go back to super step 3. Okay, so you can make your difference there in 1 or 2 of the steps, some of the steps, and still you can keep the steps that's in common. More importantly, you have a template method. The template method kind of set up the procedures, how you call step 1, step 2, step 3. Maybe you want to call step 1, step 3, and step 2. That's a different template. Okay, that's why we call it template. Okay, here it's the same, the sorting algorithm, right? First step, we have a process array, we compare, then we return the array, right? And process array maybe it's the same, return array is the same, but compare maybe differently. We have a different sorting algorithm, or we sort ascending to different order, descending order, ascending order, but so that we just need to override the compare method. But the template for this sort method is process, compare, and return. So in this method, you kind of define the template. First, define the template, and then some of the subclass, they override a part of the template to finish its own purpose. But you can still use that template to do something. So template, this word actually explain it quite good. It's a good explanation to this design pattern. Just we have a template there, and we use the subclasses to override some step from the template. Like you get a template of writing a paper, so you put all your information in there, but template is there. Okay, so here we put the template in one of the method. That's a template. how we call this step is set up in the template method. Okay. And command method, command design pattern is something. Yeah, you can think about. Yeah, here's an example. It's the idea of encapsulation, right? Because when we want to do something, we kind of make them as an order. Think about when you're going to a restaurant. You said, yeah, I want a cheeseburger, I want a chicken nuggets, or that's in McDonald's. So that's put something else, okay? Yeah, that's if we go to like a good like a restaurant where a server is coming to you, he's holding he or she is holding some piece of paper in her hand, and whatever you want to do, or whatever you want to eat, maybe a steak, a nice steak, or you want some red wine, so she will write it down, but on that piece of paper. Okay, so that piece of paper is the encapsulation of all the command. All right, so you have this red wine, you have this steak. All right, so when this, but the server, the servant, she or she doesn't care about how do you do the red wine, how to cook. They prepare this food. Okay, so they just send it to the kitchen, and kitchen will read this command. Each command, and prepare a red wine for you, or prepare the steak for you. So here it's the same. So we have this is buying a stock, something like buy stock. Okay. So here we have a stock. We have a stock class, right? A stock has you can buy stock and sell stock. So that's actually the function that's doing the thing. You want to buy stock, you want to sell stock. But as a client, we don't directly interact with this stock, right? Like as a client, I'm not directly interact with the cook, with the cooker, with the food. We interact with the broker. Well, in the restaurant, in terms of the restaurant, it's a servant. And so, what the broker do is, it takes the order and place the order. It takes order from the client and it place order to the actual place the order. When place order, the items on the order will be executed. Like the steak will be prepared, the red wine will be prepared. Maybe this is not clear enough, but when you see this code, it will be pretty clear. Okay, remember we have a interface order. Okay, the order, and we have in this order we have execute method, and the subclass or the classes that implement this interface include buy stock and sell stock. They are all orders. So buy stock, we have a function here, and execute is implemented from this order. So every order we have some execute. The execute is like it's doing the actual things, right? So remember this structure, and let's go here. We have an interface order, execute. We have a stock, class. It has a name and quantity. So we are actually doing the buy. This is doing actually the actual work of buying the stock and the sell the stock are here. Here we use this print. Okay, print with stock. We buy some stock. We sold some stock. Yeah. Okay, and buy stock and sell stock, they are implemented from the order, right? Remember, those are order. So what they do is this buy stock, that's public buy stock, that's a constructor. Okay, so when you create this order, you actually need a actual stock object there, so it knows which stock to buy, which stock to sell, right? So when you do the execute, it will call the stock, the buy function of the stock here, the buy function of stock, and also the similar in the sell. It will, when you call the execute, it will call the sell function of the stock. Okay. Right, you got the idea here, right? Right now we'll have three classes. One is stock, and buy stock, and sell stock. Buy stock and sell stock, they all have a stock as an attribute, but they are method of execute. They are different. By one of them is buy, one of them is sell. All right, here more importantly in the broker, how does broker take the order? All right, remember what are orders? Buy stock and sell stock. Those are orders. Okay, like I'm a customer. What do you want? The broker asks you, what do you want to do? The client, I want to buy stock. I want to sell stock. So that's two command, like encapsulated command on this the command to the a broker, and broker take those order. All right, broker he has a piece of paper, like I write down what I want, what I need to do, buy stock, sell stock. So here it's using take an order using a list. See the list over there, private list, order list, new array list. So when it take order, it take one order at a time and put it into the list. Like in a restaurant, you put one item on a piece of paper in the order. So every time when you order something, it will put that thing into the list. Then the broker will do what broker will do in the place order is it will just call the execute function of every order. Right? Remember what is in the execute function? Yeah. In the execute function, it actually the execute function of buy stock, it calls the buy function of that stock. Okay. Here it calls the sell function of the stock. Right? So yeah. So it's like you call the make stick function from one of the chef cooker, and you call the make prepare wine function to one of the other maybe servant. He will do that thing for you. But everything is encapsulated here. We put all the command as encapsulate all the command as a list of order. Then when we're doing the place orders, we execute all of them. Alright, like in Amazon, when you buy 10 stuff, when you buy 2 different costumes, you first take the order one at a time, and maybe they're in different areas. They are in different maybe an inventory. One of them is located in here, somewhere near here. One of them is located in California, but they all need to ship to you. So you have to take the order execute function differently, because one of them is gonna ship to you from Georgia, one of the other one is shipped to you from California. But you can call all of them here in the list. You have the list of them. Yeah, so that's a command pattern. Important thing is our command encapsulated as an order inside this list. Okay, so that's all about encapsulation command. All right, and this is a test code of it. All of this code, they are available on this website, so you can check it over there.
What's our website?
Yeah,
oh, okay.
You can see, you can I uploaded this already. I uploaded slides already. And the factory method is you're going to the factory method will return this object to you. You don't call this initialization function, like creator function of a class. Instead, if you want something, you specify what you want, it will return it to you. Like here, we have a shape factory, right? We have a shape factory. And then we have different shapes. We have a shape interface. We have different shapes. Well, we can draw a circle, draw a square, draw a rectangle, right? So when we want a rectangle, we don't like say new rectangle, blah blah. What we want to say is we use this factory as an interface to communicate for us. We don't want to learn how many shapes are there. I don't have all this knowledge information. But here I want a shape factory. I can just say get shape. We gave a parameter there, like triangle, like string triangle, and the shape factory will return you a not triangle, a rectangle here. It will create this rectangle and return an object to you. Okay, let's see the code here. See, we have a shape interface which is draw, and simply we have a rectangle, square, circle. In the draw function, they just draw differently. Here, it draw triangle. Here is draw the square. This draw the circle. It's drawing the circle. Okay, but they are all shape. They implement the shape interface. Shape interface. Okay. Can you read?
No.
Yeah.
Can you give me
Yes, sort of, right? Okay, then shape factory there. We have a shape type. So shape type is a string, okay? So shape type is a string. So the get shape function in here, you can see. Yeah, that's okay. Let me. Shape factory, right? Okay. So see the shape factory, we have a get shape function. Get shape function, which return the shape. Shape is interface, and under the shape we have circle, triangle, rectangle, right? So here we have circle. We have this get shape function, which what you want to specify is a string. Like I want a circle, so I just type in the circle. Then it will like shape type. It will return a new circle for you, and then you specify the rectangle. It return this rectangle for you, or specify a square. Okay, that's just an example. You can also specify maybe the radius, the position, the color of this of all these shapes. Okay, it will return that. It will generate for you from here. So importantly, you don't need to know if there is a square or something like rectangle there. You just specify what I want, and it worked as a factory and give you what you want. Okay, so the factory has its template to create things, to create shape, to create circle. Okay, but here we create these shapes, not directly create the shape object. We create the shape object through this factory. Okay, so that's why we call it set factory. All right. Okay. All right, and MVC, I think model view controller, MVC. I think you heard that a lot, right? What is MVC?
Model view control.
Yeah, model view control. Yeah.
So
Yes.
they have
The main idea of it.
They have a business model, and then they have a view, and then they have a controller in the middle.
Yeah.
Yeah.
So that's also a design pattern. It's actually a similar idea, maybe to a structure, software structure, and this design pattern. We have an MVC, model view controller. Okay, so we want to separate model view and controller. So what's your question?
Is MVC an architecture or is that design?
Well, can you like separate design pattern and architecture? Sometimes it's hard. It's just when you are doing the design pattern, sometimes you design for the architecture, right? So MVC is one of the design pattern, definitely, and it's sometimes we call it an software architecture, MVC, yes. So it's an architecture of software, and it's also a design pattern. So we design this software architecture for the software. So either way, but MVC, the main idea is MVC. We separate the M, which is model. Here, student is a model. Okay, so student has all this name information and the ID number. Okay, so we have set and get for the name and ID. All right, and we have a view there, which just shows the information, showing the information or something like that. But the view and the model, they do not directly talking to each other. They talk through the controller, all right? So the controller have the access to both view and the student. You see, it has a model, it has a view, right? So it has a student controller method. Student controller has a student controller method, which is the initializer of the student create function of the student controller. It has the set student name, get student name, and set number, get number, and update view. So from this you can guess the set get, they talk with students, right, and directly call them, and the update view they get this they talk to this view to maybe get update the view to show different, to print the information of the student. Okay, and also when you are doing some modification to the student, you do not directly talk to the student. Okay, you go through some kind of going through the view, and the view will talk to the controller, say I'm gonna update this model, so the controller will update this model for you. Okay, so that's a code. The student, it has a number, name, right, strings, and set and get, right? The student, this is a model, like a data in the database. Okay, and student view is kind of it's just a print. Okay, print. Here the student view only has the functionality of show the information. Sometimes you also modify through the view, and the view talk to controller have to modify in the model. Okay. Here we only show example of the view, just a print. And we have a controller. Controller have this. Controller have two members. One is the model, one is the view. What it does with this model is set and get. It get string. It calls the model's get name. Okay, and the set, it called the set name of the model. And this a student number is the same. And update view is actually called the print function of the view. Right, so it's controlled by a controller. It's not directly talking to each other, the controller and this view. Okay, so what is the benefit of doing this MVC?
It separates different functionalities, and so you can work on each differently, and if you need to change something, you can concentrate on one side and change that.
Yeah, a lot of things. So basically, still the object-oriented thing. Like when you separate them, so first it's more flexible for change. Like later you want to use a different database, right? Or the model change. You don't have to go all the way into the view and change everything in the view, which is mass. So you do it here. You just replace it, and then change something in the controller, probably in the set and get, or something like that. Different, like before you're using circle, then you're using some non-circle, something like that. Or probably there's another layer here to help do that. You don't even need to change the controller. But the logic is in the controller. When you want to change the logic, how this thing work, you do it in the controller. When you want to replace database, you can just do with model. When you're trying to modify the UI, you do it in the view without touching the other three of them, without touching the other two. Yes?
Let's say we want to create another view. So do we have to create a new MVC for that, or can we integrate it in there?
Sure, you can have another view. Like this is student just showing the information. So if you have a bigger system, you have a student, professors, and then you have a view like showing the information view of every professors and every professor and student. You can just have that view print every information. Probably it will call the controllers every get method of the controllers. So you don't have to create another. Why you want to create another MVC? So still it's in the same logic. We just to get the information and create a new view. It's simpler. Probably here you want to print all the information, and later if you have another view, I want to have another view which just show the information, show the name of the student without the number. Probably want to protect something, protect the privacy. Okay, maybe hide some information there. You can do it in the view, right? Just show the information there. And this is the code there. Yeah, student view. And that's the student controller. Yeah, I talked about that. And decorator. Well, decorator is different. So decorator, it works as when we have a class already there, provide some functionality. When we want to extend the functionality of that class, what would you do? Yeah, okay. So the most straightforward way is we put some new method in that class, right? But here in decorator it's different. We create a new class, which is wrap the original class. Okay, wrap it. It have the original class inside it, but it's a new class with some additional functionalities there. Like here, the shape is the interface. Okay, we have a circle and rectangle, and then we have a shape decorator. Okay, shape decorator, like this red shape decorator. It extends this all this circle, because the circle, rectangle here, they only have the shape, they don't have the color. Later on, when we want to have a color for all the shapes. So instead of I'm overriding this, I'm changing the shape interface to have a color there. We have this red shape decorator, which is also a shape. It's also a shape, but it has a shape as its member, and it has additional functionalities here, like red shape decorator, set red border. It put a border around the circle, around the rectangle, something like that. So it's more clear. We have interface shape. We have a rectangle. We have a circle. They all print rectangle, print circle. All right. And we have a shape decorator, which is also a shape, but it has a member, which is a shape. Okay, you got what I mean? So that we can include the original circle or rectangle there. So it has a member. And then this red shape decorator is actually a subclass of this shape. So it is also a shape. Theoretically, basically, red shape decorator is also a shape, but it's a shape that built on another shape. Okay, so it has importantly, it has a function in the draw function of this shape. It calls the first calls the original draw function of the rectangle. Then upon that, it set the red border on that shape. Okay, so this is set red border, like system out print border color red. Right. So it's we use a class which is still of the original type, but within that class we wrap another shape. Okay, like red shape. Red shape, we wrap the original shape. Red rectangle, red circle, something like that. So it's a wrap around the original class. Okay, another thing is adapter. Adapter is okay. So here we want to connect my computer to this projector. Right? If I don't have this HDMI, if I only have this Thunder port, which most of recent Mac only have the Thunder port, okay, I have to have an adapter there, just like trying to convert the input to the output. Maybe those two, we have two classes, they have their own interfaces, but they don't match. We need if we want these two classes, they kind of work together. We need an adapter in between, right? Like my computer doesn't. If the computer doesn't have HDMI, if it only has like VGI, then I need a adapter from convert one signal to another signal. So here the adapter is the same. Here is a audio player. Okay, it only plays the MP3. But here we wanted to kind of want to have an advanced media player. It has the functionality of play MP4, like the videos thing. Okay, so if I want to have a media player that kind of work with this advanced media player, since they cannot directly talk, then we have this media adapter to help us do this. Let's see the code here. So we have interface media player, which is a general media player. We have two interfaces here. One is media player, one is advanced media player, which has more functionalities. The media player only play the maybe MP3. Alright. So we have advanced media player is another interface, but it plays different things. VLC MP4. Okay, and we have a VLC player which is an advanced media player, and we have an MP4 player which is also an advanced media player. So it plays MP4, it plays the VLC, but in the MP4 it does nothing. But the MP4 player doesn't play the VLC. All right. So we have another thing called audio player. Okay, so it's basically a media player. It doesn't play MP4. It doesn't play VLC. Okay, but it does play the MP3. See here. Here is the MP3. Okay, I have the function play MP3. It's fine, but yeah, I have the function of play MP3. But I don't have the function of play MP4 and VLC. And so if I want to extend this functionality of audio player to play as well as VLC and MP4, I will need to use the functionality of the VLC player and MP4 player, right? However, when they are created, we didn't expect they're gonna talk to each other, right? So I don't know how to make them talk to each other. So that I need a media adapter. Okay, we need a media adapter to help us to do the play. Okay, so here, yeah. So here is in order to create this media adapter, we kind of need the information of the other end, like VLC player. We need a VLC player. We need an MP4 player. And when we are the play method of this adapter is kind of, if it's a VLC, we call the corresponding method from the object. Okay. So here in the audio player, it actually talks to this. If the audio type equals to VLC, we use the play function. We use the play function from the media adapter instead of the play function directly from the VLC player. Because first, I'm not sure if there is a VLC player there or MP4 player there. Or maybe we have an MP5, MP10 file there, but we don't know if those are there. However, this adapter has information. If we Because then if we extend this advanced player with MP5, MP6, MP7, okay, this we can do that, and we just need to modify the adapter. And then in this media player, we don't need to do anything. We just need to talk to the adapter to see if the thing we want can be done there. Okay, so like adapter working between to switch, to change the one that input from to output to another kind of output or input. Yeah. And for state, so this yeah, this is the last one I'm going to talk today. All right, so we have a shape interface here, and this is so simple. I don't even need to show this code here. Just you can read it from the template, the class diagram. So we have a shape interface. We have a circle, rectangle, square. You can guess what's inside, right? System print, or the system print thing is what we want to demo, okay? But it's the actual draw method is actually cause a lot of different algorithm to if you want to draw something on the screen. Okay, it's not like just print. The print is just for the demo example. We have shape and we have different shapes, and if we want to try to draw the shapes, it asks the shape maker to create one of the shape for you. Okay, so the shape maker, it can have this circle, rectangle, square, and if I ask like if I want to draw the shape, I want to draw the triangle, you call the shape maker, and then you call the triangle. So it's kind of like interface. It's similar. It's pretty similar to I'll say this maybe factory method or something like that. It's pretty similar to that. Yeah, factory method actually give you that object. Here it's just draw directly. So kind of similar. So we have all these shapes here. So we can keep on adding those shapes. Okay, but my client, I'm not interested in how many shapes are there. Okay, I just want to do my logic, do my job. So I only talk to this shape maker. And shape maker work as an interface between all these shapes and the client. Okay, so all of this design patterns, they kind of want to give you this idea. First is encapsulation. Want to group things together and trying to make them more flexible, right? And information hiding, encapsulation, and sometimes we use the interface, and we want every object class to do their own work. Circle is drawing a circle, nothing else. Client, we just do my own business, and the shape maker does its own job to do this. The good thing about this encapsulation is adaptive to changes, which is quite important, and is like the very important value of object-oriented design. That's a benefit, main benefit of it. Okay, so and it's but we have different ways. Like the wrap is a kind of another idea. The wrap is we have something inside, we extend it, we wrap another around it, but we don't touch this thing, the origin thing, right? Here is we create an interface. So for that, I don't touch the origin thing. So when we're trying to make change, we want to touch as less as possible those classes. Okay. In order to do that, encapsulation is a good idea. And all these design patterns, they kind of have a different scenarios to apply them. Okay. I cannot talk every single detail. We don't have a rule. Like under this scenario, you use this kind of design pattern, because it's hard to set up that hard rule. You have to judge. But in order to judge, you have to know what are all these design patterns, okay, and how they work. But those patterns I talked here, they kind of representing what like the main things of the design patterns, and you can learn more details and you can learn more patterns there through the website I gave you. Yeah, that's just it's based on this object-oriented design. We have all these patterns available to us, which can save us time, build up confidence when we are doing the design, and also help you to obey this or help to stick to the principles of the object-oriented design. Yeah, questions?
But for some reason, I don't see the point of having interfaces. It's just like a contract for them to do, right? It's just what's
Shape maker.
Without interface, you can implement all this, right?
Well, I mean, this facade pattern, this is really just giving you a simplified way to access all that.
Yeah. So
It simplifies it.
yeah, I don't. When I create more and more shapes here, I don't have to inform that my client. Okay, maybe I have more client. Maybe I have more than one client. Okay, so like I am a manufacturer. Okay, I cannot give that example, but here like you have 100 of the client. You can have hundreds of clients. So when I have a new product, one way is I send all the email to 100 of them. Okay, like I have this new product. Do you want to try them out or something like that? Or if you want to try them out, you have to put this thing into your system and call this method. Okay, so that's one way. And there are hundreds of modification in those classes. But here, when I do one thing, I just need to update one thing in the interface. That's it. Okay. And later on, the client, when the client talk to the interface have all those information there available. So you can just call, like draw rectangle, draw triangle. Okay, so draw triangle, draw something else, or draw red triangle, something like that, so that you don't have to make too many differences, too many modifications there in the client. Okay, and you have this interface which tells you everything. And we have only one of the interface there, which make it consistent for every client. Okay, but if you want to update every 100 clients, maybe you have bad programmer there, which creates something horrible and call you. So this is not working at all. I'm gonna done. I'm not gonna like work with this company anymore. Something like that, right? So you need only one modification there instead of 100 modifications somewhere else. Okay. So maybe that's one of the value here. All right. Okay. So yeah, that's it for today. Yeah. Yeah. 20 minutes over the plan.